Good morning, everyone. I'm Yves Lamoth, and I work for the Exploration Ground Systems here at the Kennedy Space Center, the world's preeminent launch complex for government and commercial space access. As some of you may know, massive structure behind me here called the Crawler Transporter 2. To put it in perspective, the Crawler Transporter is what will carry the mobile launcher along with NASA's Integrated Space Launch System rocket and the Orion spacecraft to the pad. Not only do we do things big and we do big things, but we have big news and we're excited to share that with you. We're getting ready to undergo testing where we're going to use the Crawler Transporter, the Vehicle Assembly Building, the Launch Control Center, the pad, and the Crawler Transporter to do testing here at the Kennedy Space Center. For the first time tomorrow, the Crawler Transporter is going to take the mobile launcher to the pad. And to talk to us a little bit more about the Crawler Transporter here, I have John Giles, who is the Crawler Transporter's project manager, and one of the Crawler drivers, Sam Dove. Now, folks, as we're doing this live for you, please feel free to submit your questions, and I'll be able to ask on your behalf. So to kick things off, John, can you tell us a little bit more about the Crawler Transporter?
The Crawler Transporter was originally designed and construction began back in the early 1960s. And large pieces of it were shipped here to KSC, where it was assembled into the crawler that you see here now. We made its first roll in approximately mid-1965, and it has served well for the Apollo program and the shuttle program, and then of course SLS program will be doing everything it needs. And the one big change after the end of the previous program was we have to be able to pick up more weight. So the SLS program said they wanted us to be able to pick up 18 million pounds. The previous amount was 12 million pounds. Kennedy Space Center and the Ames Research Center out in California, which they did all the analysis and determined exactly what we needed to change or replace or upgrade on this crawler. And then we started instigating all of those projects, things like putting in new bearings so they could withstand the extra weight, putting in the new hydraulic cylinders so they could lift extra weight, and some other structural strengthening mods.
Okay, very well. So to get more in depth about what the capabilities of the Crawler Transporter is, right, we're going to talk a little bit to Sam Dove. Sam, exactly how long does it take, to drive the transporter from, say, where it is right now over to the pad?
Well, normal speed, which is 0.8, 0.9, you can make the trip in probably about 7.5 hours. You have a number of hours to prepare for things that you have before you move and after you move when you get to the pad. Generally about 12 hours or so right in there if everything goes well.
12 hours. Now, I imagine, is that one person sitting and driving the transporter the entire way, or is it, do you do it in shifts?
No, we have a team of approximately 30 people, and we have some NASA folks that go with us as well. And we take and the driver goes and he drives for 35 to 40 minutes. And then we have people in the control room watching the systems, controlling the systems, a test conductor. And everybody rotates approximately every 30 to 40 minutes. And that way you're not just stuck on one thing and you don't get fatigued that way. And you can stay sharp and see what all's going on with everything that has to happen.
That is absolutely amazing. Now, this is such a massive, massive, massive structure. So is it... How exactly do you turn this thing around? If, say, you were on your way to the pad and you needed to come back, what would you do in a situation like that?
Well, you don't actually turn it around. It just goes one way, and you have two ends on the crawler, end 1 and end 3. And so if you're going to the pad, you're always going in the end 3 direction. If you're coming back toward the VAB or the crawler yard here, it's in one direction. So if you have to stop and come back the other way, you don't actually do the 32-point turn to get around the curves. They just straight out, straight back.
Oh, wow. Now, so being a driver, what does it take to become certified to be able to drive such a massive structure?
Well, first of all, you have to have an engineering degree, and you have to be in the Crawler Transporter group. And then you go through an on-the-job training program, which includes you have to know and start as an entry-level person coming in and learn all the systems, how they work, how they apply with each other, how it affects actually certified to drive by yourself.
This is from Instagram. And the first question is Sam driving the crawler the entire time? At what speed? How long does it take to get to the launch pad? And I think you sort of answered those questions already, right? So it's not him the entire time. There's shifts about 30 to 45 minutes. It goes about 0.8 to 0.9 miles per hour. And it takes about 12 hours for us to get, from the VAB over to the pad. Great question. We'll take another one. The question is, and maybe John, you can answer this one, is this the same crawler from Shuttle and Apollo?
Yes, we actually have 2 crawlers. So these 2 crawlers have handled every program here at KSC.
And we do not exceed 0.3, either up or down, whether we're loaded or unloaded. And that way it gives the jacking, equalization, and leveling system time and enough time to react and stay level. Because you are still dealing with hydraulics and it's not super instantaneous. You have to give it a second to keep itself level and all.
Okay. So, John, we'll kind of go back a little bit to design, right, and what this was intended for. Now, at these kinds of speed and the size of this structure, how long do you think it would take for it to, say, travel from here to the moon?
We had that question, and so I needed to go do some math. So I went and checked it, and we're roughly 239,000 miles to the moon. Figuring if the crawler was going at 1 mile an hour, it would take roughly 27 years to get there.
27 years. That is absolutely amazing. 27 years just to get from here all the way to the moon. So actually, amazingly large structure. And again, this is how we do here at KSC. The space business is a big business, and it takes a lot for us to get from here to deep space. So we have another question here from YouTube. This is user Bo, and ask, how long does the prep time on the crawler take, and how much grease is used?
We use quite a bit of lubrication. The prep time depends on what you're really going to do, the mission you're going to do, but we replenish all the oils, the greases, the lubrications, and refill the crawler. You probably use, probably a couple barrels of lubrication for the tracks. You can see the tracks behind us, and they're a little greasy right now, too.
That's a 55-gallon barrel.
55-gallon barrel. Yeah, it's true. And for the pin spray, which keeps the pins, as you can see, that hooks the belts together, that pin spray, we usually go through about a barrel, a 55-gallon barrel, and maybe a half per mission.
Wow. Yeah. Now, earlier you talked about a team of about 30 people that it takes, when this thing is on the move. Is that 30 people the entire time? So I imagine there's going to be some people walking on the floor. There's some people on the deck. There's people in the cabin. How exactly does that work?
Right. Well, we have observers on the ground, usually one on each corner, to help the driver and make sure that we don't get over too far or get in any kind of trouble in the curves. We have guys in our pump rooms and engine rooms, and we have guys walking around, laying hands on things, making sure it's good. Because you've got good instrumentation, but you want to keep your folks involved, because there's nothing can beat a person down there making sure everything's good. And all those guys rotate through too. They don't spend the whole time walking on the crawler. And they spend time up in the engine room, the pump rooms, down on the down on the side watching. They spend time on break, and it's just a continual rotation of people.
Gotcha. Now, John, being that the crawler has been used for multi-programs throughout the many programs here at NASA. Now, if for some reason we needed to upgrade the crawler transporter to carry even more weight, is that something that's actually possible?
I think so. We would have to do another analysis to figure out how much more weight we could carry. But sure, we can do that.
Okay. Very, very well. Very well. All right. So we'll take some more questions from our watchers here. We have another YouTube question. So the question is, how much does the crawler weigh?
Well, right now we're just it's about 6.6 million pounds, just a hair over that.
Now, let me ask, how exactly do you know that?
Well, during the mods, we actually picked the trucks up. We had a company come in, blocked underneath, and we picked the trucks.
Again, amazing. Here at KSC, we do things big. All right, so we'll take some more questions.
So while you're looking for another one, actually, I could tell you, back on the laser system, even though Sam described we don't use a laser system to level the crawler, We are going to implement a laser system that lines us up for driving underneath whatever we have to pick up. So we are going to implement that, so then that'll give us precision alignment, because we have to be pretty precise when we roll underneath things so we can pick it up and so it's balanced.
Absolutely. Amazing. All right, so here we go. Our next question is from Twitter, and Mike asks, does the crawler, and folks, keep the questions coming in. Thank you for staying involved. This is a question from YouTube. This is John Burkett asks, is the road surface prepped before a load carry? And I imagine that, I think he's talking about the pebbles that are on the ground here.
Yeah.
Yeah, absolutely. It's conditioned every time, and they pull the gravels out, get all the hills and valleys out, all the furrows where people's running across it, get it all nice and level for us, and it makes a nice smooth ride for the crawler when it's like that.
And this has to be done for every single time that the crawler is carrying a load out there?
Sometimes we don't, because we're looking at crawler weight things. You know, we want to see how the rocks are holding up and everything. But for every major move and for every mobile launcher move, every move with flight hardware, it's always conditioned and groomed.
Gotcha. Okay, very well. Another question from YouTube. This is Space Girl asks, when will the tower be moved? So as I mentioned, for the first time tomorrow, the crawler is going to be picking up the mobile launcher and taking it out to the pad to undergo the testing. So that's going to be coming up tomorrow, folks. So please make sure you stay tuned. Stay tuned with us the entire week, as we have so many activities going on with all of that. All right, this is a question from Facebook. This is from Peter Mazzi. Ask, how does moving the mobile launcher tower with the SLS, which is the Space Launch System, compare to moving the mobile launcher launch umbilical tower with the Saturn V on it?
Well, when I first arrived at KSC, I was fortunate enough to work with some of the Apollo guys. And, you know,
Can I ask how many years ago that was?
You can. No, I started in '87 here. Yeah. I was very fortunate to be mentored by some of these guys, and they would always impart to us, you know, the stories of the rollout with the tower and the Saturn V. And from what we've seen, we've moved this mobile launcher before it was all modified and all outfitted. We moved it twice already, and it'll be very similar, but we're going to wind up with a heavier rocket when we go with that, a bigger rocket. And the crawlers, just think about driving your truck down the road empty versus having bags of cement or mulch in the back or something like that. It rides a little bit different with that weight. I suspect it'll be kind of very similar. The tower will move around a little bit just like it did in Apollo, but the crawler's well suited to handle it, and I think it'll be a successful rollout. Pretty much the same thing.
Very good. Amazing. Okay, next question. Steve Evan asks, how quickly can it stop?
Well, that depends. First of all, it's how fast you're going. At 0.9, if you stop the crawler, and for instance, just take your foot off the gas, or you hit what's called an emergency stop, it will roll approximately 20 feet, 25 feet. If you apply the brakes, it will stop much quicker, and we try not to do that because we don't want to rock. We don't want to rock our payload, damage the rocket or anything in a way. So generally, if you stop, you just let it roll to a stop.
And it comes to a stop. Okay, very good. All right, ladies and gentlemen, we are getting some weather warnings here right now, so we're going to go ahead and wrap it up. I'm going to go ahead and ask just one last question before we're done. But on behalf of the Kennedy Space Center here, the Exploration Ground Systems Program, thank you so much for participating. We're very excited to keep you in tune with everything that we have going on. Our last question is going to be from Jim Thurman, and the question is, why does NASA use those particular rocks on the pathway?
Well, they did a study, of course, and you have to look at the size of the gravel, the roundness of the gravel, and what the makeup of the gravel is, of the rock. And what that does is it helps the frictions for steering and spreads the support out underneath the shoes. But mainly, it provides you a good smooth path to steer the crawler with, as opposed to being on concrete or asphalt. And so it helps you when you steer around the curves, a little less friction, and makes it a lot easier on the crawler.
And then one other thing too is the crawler doesn't have a suspension system. It doesn't have shocks and springs like a car would. So the actual crushing of the rock absorbs any vibrations and gives our payload a smoother ride.
Very well, very well. So, folks, once again, thank you so much for tuning in. Keep the questions coming, and we'll do our best to answer as many of them as possible. Thank you for being here with us and being part of everything big that we have going on here. This is, again, Yves Lamoth with the Exploration Ground Systems Program, and we'll see you guys next time. Thank you.